Hey guys, welcome back. Today we're tackling problem 419, and now we've moved on to the next section of chapter 4, which deals with couple moments. Couple moments are they're pretty much two when you identify two forces, like here we have these two forces that are equal in magnitude, just different directions, and they're separated by some distance r. Okay. All this does is cause pure rotation. Okay. So like a steering wheel, right? Here's the center, and we apply a force here and a force here, and then all we have to do is if we were able to calculate how much force we're actually applying to the steering wheel, and let's say it's half a meter, okay, it'll be the couple moment, or the moment produced by that couple, would be 0.5, right, times F. Okay, so you don't have to take the moment about a specific point and then do let's see, F2, and you wouldn't have to do like this, like R1 cross F1 plus R2 cross F2, right? Just doing the force, the given force, times the distance between the two, okay, will give you the resulting couple moment. Okay, so let's apply that here. Okay, so first let's identify the couple moments in our system. So here I pointed this one out, the 400 Newton, right? They're non-collinear. Okay, we have 400 newtons and 400 newtons going up. Then we have these two, okay, and then we have this one and this one. Okay, so let's look at this 300 Newton one. Okay, and I'm gonna go a little more in depth in explaining the concepts here, as so we don't have to do it for the rest of the videos. Okay, so this is kind of like the steering wheel example, right? A force is being applied in this direction, and a force is being applied in this direction. So this beam wants to rotate in a clockwise direction. Okay, think about your steering wheel. Okay, if that was your pivot point here, okay, you would want to rotate about that thing. You'd want to make the beam rotate, in this direction, and then the next position like that, and so on. Okay, so let's take that into consideration now, and let's call it M1 for the 300 Newton. So it's gonna be, let's do the force first. So 300 Newton force, okay, times the distance between them, okay, so times 5. Okay, and now what direction is it? We said it was going to be going clockwise, so it's going to be negative. Okay, so we have our minus 1500 Newton meters. All right, now let's do the first one that I pointed out before, M2. We're going to tackle the 400 Newton force. So we have 400 newtons, and then the distance between the two. Okay, I said it was just going to be 2 meters. All right, and then which direction does this want to rotate? Well, let's push this. If this was the center right here, this would want to rotate it down, and this wants to go up, so it will rotate counterclockwise. So we have a positive 800 Newton meters. Perfect. And then the last one we can see here is this 200 Newton force. Okay, so then M3, right, it'll be the 200 newtons. The distance between them, right, it'll be 0.2. Okay, and also perpendicular distance between them. So the distance between them has to be perpendicular to each one of these, as seen right here in this 400 Newton force. Okay. Sweet. Okay, 200 times 0.2. That would be, let's see, 40. 0.2 times 200. Nice. Okay, my brain's still good. 400 Newton meters. And now let's identify which direction. Alright, so this wants to pull it in this direction, towards the right. This wants to pull it towards the left. Okay, so it's going to be rotating clockwise. Okay. So now, what is the resultant couple moment acting on the beam? Okay, the resultant couple moment is just going to be the summation of all those. Okay, so if they added up to 0, this beam itself would not rotate at all. Okay, everything would counteract each other and equal 0. But it's probably not going to be the case. So minus 1500 plus 800 minus 40. Okay. So now let's see. Minus 1500 plus 800 minus 40. So we have a minus 740 Newton meter couple moment. Okay. So let's see. Which direction is this? So you can place the resultant couple moment anywhere on the beam. Okay, because it's like the book says, it's a free vector, meaning it doesn't matter where it is. Wherever it gets placed, it's just going to cause the object to rotate. Okay, so I can just say, okay, it's here, and it's going to be 740 clockwise, so it's going to go in this direction. Okay, so that's MR, and I can just say 740. Okay, as before, the negative 700, most of the time, or all the time in my videos, we have, actually let me turn the arrow here, we have counterclockwise is positive. Okay, so if this thing is clockwise, it's going to give me a negative. Okay, alright guys, thanks for watching. Leave some comments below, and I'd also love to get some feedback in regards to, you know, things that I should explain a little more clear. You know, do the colors of the background annoy you? Is it good doing yellow or navy blue, like a darker color? You know, should I go a little more in depth with the mathematics behind it? Let me know. I'll be happy to answer all these questions, and I'll definitely take your feedback into consideration. Thanks, guys.